Hello and welcome to Technology Update. This month we're embracing the snowy season to bring you some of the latest innovations from the world of winter sports. To kick things off, we're here at the Roza Hutor complex in southern Russia, where the tracks for the Sochi 2014 Olympics are facing their first test. Just a week after the first Russian Cup stages wrapped up in mid-February, 60 athletes from 12 countries christened Roza Hutor for a stage in the Alpine European Cup men's downhill. Rave reviews were won by the brand new track, the first of its kind in caliber on Russian soil. The top time, however, went to Austrian Manuel Kramer. Back in September 2009, we showed you a rawer version of Roza Hutor, already under construction, but with a great deal of work ahead. A long-envisioned resort complex along the Aibga Ridge gained new attention as a key part of Russia's Sochi 2014 Olympic bid, and the complex has come a long way in a short time span. The technical backbone of any world-class ski area is an extensive and efficient set of lifts. To make sure that Roza Hutor had the best, no expense was spared, with total costs estimated at €650 million. The result in 2011 is Stage 1 completion for the enjoyment of average ski enthusiasts as well as international stars. This season, 4 of the projected 18 lifts are up and running, opening up 38 kilometers of new runs. Helping thousands of visitors reach Roza Hutor's heights is the Russian aerial lift producer SKADO. SKADO's production facilities in the Volga River city of Samara are the birthplace of this high-tech, high-altitude hardware. Along with their world-renowned Austrian partners Doppelmayr, they cover over 3/4 of the alpine lift market in Russia and the CIS.
SKADO is not a newcomer in the industry. I myself have been running the company for over 25 years. It's an enterprise with a long history of constructing ropeways. SKADO is behind virtually all aerial lifts in the former Soviet Union. We designed, supplied and set up the hardware for them.
Variations of the elevated ropeway have been used for many centuries, but the real boost came with the invention of the steel rope. Aerial cargo transport was adopted by many industries because of its relatively high speed and low cost, particularly for mineral extraction in complex terrain. In the second half of the 20th century, enthusiasm for alpine skiing experienced a worldwide boom, and the Caucasus Mountains in what was then the Soviet Union were no exception. With a unique climate and many of the highest peaks in Europe, resorts popped up throughout the region, demanding developed infrastructure. It was a task tailor-made for SKADO, whose aerial lifts played a vital supporting role. Today, SKADO is a post-Soviet private company with the same passion for aerial transport systems. Modern lifts require mass-scale metalworking to turn out sturdy bull wheels, precise guide rails, and monumental support towers. Time-tested welding techniques help ensure ultra-durable strength joints. They'll be further inspected with X-ray, ultrasound, and magnetic tests. It's a slow and tedious process, but the skilled personnel has to make sure that each part is capable of withstanding not just the cargo load, but also the cold, the wind, and the pressure nature is sure to pile on.
Since 1997, SKADO has set up more than 250 installations across Russia and the Commonwealth of Independent States. Depending on the level of complexity, SKADO's input ranges from 100% in the case of surface lifts or fixed grip chair lifts, or it could be 50 to 60% if we're talking about advanced ropeways. I mean very complex transport systems, including high-speed lifts with higher passenger capacity.
With human lives literally in the balance, the metal underpinnings of aerial lifts have to be absolutely fail-proof. A process called hot dip galvanizing is employed on SKADO's constructions by partner firm and Samara neighbors Prodmash. This is molten zinc, not a bath you'd want to jump in to escape the Russian winter. The zinc bonds metallurgically to the steel and forms a protective layer. As with any steel or metal installation, the towers and beams that hold up ski lifts are susceptible to failure from rust and corrosion, the dangers of which are elevated, in this case, by harsh weather conditions. Hot dip galvanizing offers more than a shiny exterior. It should add to the structure's lifespan by resisting these forces of nature.
At the end of the 1980s, at one of the international exhibitions, I got acquainted with the managers from Doppelmayr, the Austrian company which is the world's leader in ropeway design and construction. In 1997, after long negotiations, we finally agreed to establish a joint enterprise. At that point, we had developed our own unique technical solutions, but we also wanted to introduce Doppelmayr's cutting-edge ideas in the Russian market.
Doppelmayr has become a household name not just in the famous Austrian Alps, but around the world. To date, the company has built more than 14,000 installations in over 80 countries. SCADO specialists travel frequently to Doppelmayr for training, and the partnership has helped the Austrians enter the growing Russian market.
We have a theoretical calculation in Austria. So our partner set up the installation in Russia. So I have the theoretical results here on my protocol. Then I check the praxis. We check the brakes. The second test is the tension system, for example. You have the right force and the right load. And the third check is the conveyor belt. So SCADO makes the towers. He manufactures here in Russia, and in Austria we make for example, the station with this factory in Austria, and so we can very good work together.
Planning and building mountain lifts for ski areas is no overnight study in engineering. It calls for painstaking geographical and topographical analysis. SCADO handles the full cycle from site inspection, design, and planning proposal until the poles are up and the chairs are full of snow-seeking skiers. To get there, they spend weeks in the field, making sure the right route is being selected. The task is a careful balance between cost-effectiveness and ease of engineering. Not every lift can be laid along the shortest line from point A to point B. Often ski lodges and base areas are located in easy proximity to access roads and parking facilities, leaving SCADO's lifts a lot of work to get you to the slopes. As practice in the Sochi 2014 Olympic ski area has shown, they're up to the task.
When the International Olympic Committee visited Krasnaya Polyana to decide whether Sochi was eligible to play host to the 2014 Winter Olympic Games, the aerial lifts set up by our company were the only technical installations that were up and running at that time. They were showcased for the IOC Evaluation Commission.
SCADO has been building in the Krasnaya Polyana cluster since the 1980s, when it first put up 4 lifts at the Alpica Service Resort. At the nearby Gazprom complex, SCADO has constructed 6 modern lines, including 1 8-man gondola, 1 6-person chairlift, 2 4-chair lifts, and 2 basic T-bars. The newest additions are at Roza Hutor, the Olympic ski hill where SCADO is behind 3 8-person gondolas and 1 6-man chairlift. In addition, SCADO will help build what their website claims will be the longest tri-cable people mover in the world, to take skiers and eventually Olympic spectators from the future train station to the Laura Gazprom complex. Right outside of Moscow, Snezhkom is a SCADO-built all-season option if you want to hone your ski or snowboard skills before the trip down to Sochi. It may be a beginner hill, but the show-offs were still making me nervous about my first ever snowboard attempts. SCADO's lift solution for the concave curved enclosed complex was impressive, but already the least of my worries, as Natasha tried to get me started down the slope. Sliding cautiously, I wasn't the fastest learner, and despite helpful coaching, I was starting to wish for more familiar skis, since I seemed to be spending the lion's share of my time on my backside.
Whoa! All right, fortunately a spill like that doesn't hurt so bad thanks to the snow that they've got here in bunches, but if I'm going to go on a real mountain, I clearly need to figure out how to train myself a little bit better than this.
Luckily, I didn't have to look too far. In the same Snezhkom complex, Russian inventors Mikhail Manuilov and Yuri Mashinin have set up a training center using their one-of-a-kind SkyTech interactive carving simulators. In a market full of gym equipment for advanced athletes on one end and video games for casual consumers on the other, the tandem found a useful niche and filled it by combining and improving the two. The result is an incredibly realistic training and exercise experience. The physical interaction mirrored the slope a short while earlier, only now with a more impressive landscape and gates for targets. As Yuri coached me on, the elusive key here was finding and properly controlling my balance over the board. Obviously, my form leaves much to be desired, so let's break down how a properly trained athlete would look on SkyTech's simulator. Pushing off of one edge, the skier or snowboarder has to transfer their weight fluidly from side to side, while maintaining a forward center of balance, just as they would crossing and then turning on a real slope. Here, the contours of that slope are imitated by electric motors. The skier board frame rests on rails and is pulled by steel ropes connected to the motors and reduction gears. Optoelectronic sensors detect both the edge angle and position of the rider, relaying this information through the computer to the motors to simulate a turn and to the software to reproduce realistic motion on the screen.
The steel is made in Russia. The software and powertrain have been developed in cooperation with our international partners. The first prototype took a year to make and test. Currently, we need 3 months to put together a simulator from scratch. If you place an order for a model and we already have the spare parts for it, we are ready to supply the final product within a month.
Back on my simulated board, I was starting to get the hang of it, and a serious workout in the process. Before long, Mikhail was able to personalize the experience and crank up the difficulty, increasing my speed, altering the course, and penalizing me for missed gates, as Yuri corrected my form and even cheered me on.
The technology gives us the ability to control the characteristics of the slope on the go. The software allows the instructor to change the position of the gates as needed. These features make the training incredibly efficient.
Meaning you could change anything we see? How about adding an RT logo?
Absolutely. You can add any objects to our virtual slope. Here's the part of the code for the banners where we can place your logo. The banner will show the name of your channel, RT. So now we take the banner up onto the billboard, right? Now it's ready and off we go.
A familiar banner was a nice bonus, but still more encouraging was the increasing speed, the sound of hitting the gates, and the feeling that SkyTech was making a boarder out of me.
The simulated workout you just had was in the traditional 2D format. I think you'd agree it was very realistic, but recently we have been testing our system in 3D. We can try it out right now with the help of these stereo glasses.
Oh man, it's the real thing. After this, I can't wait to hit the mountains. While I'm enjoying my newfound snowboarding skills, it's easy to forget that not all the Winter Games are going to be on the slopes. Innovations are also popping up in preparation for other events. On the Black Sea coast, less than 50 kilometers from Krasnaya Polyana's mountain cluster, the future Olympic Village, parks, stadiums, and arenas are rising up in the city of Sochi itself. Technology Update first covered the state-of-the-art construction in its early stages back in late summer 2009. And while best-laid plans were already breaking ground, they've come a long way in a year and a half. From foundations and frames, the future venues have begun to take shape. The Bolshoi Ice Palace will be the centerpiece of the complex, built for the Olympic hockey tournament and training. It will play home to hockey heroes from around the globe, along with hordes of flag-waving fans to cheer them on.
The Bolshoi Ice Palace you see here will host the hockey medal games and can hold up to 12,000 people. We finished work on the frame of the building, made of solid cast reinforced concrete. As you can see, we've also mounted the 17 arched girders of the dome-shaped roof. Now we're working on the roof itself. 42% of the construction has been completed, which means we are right in line with the building schedule.
On schedule in this case means not just ready for the February 2014 Olympiad, but even earlier by late 2012, when Sochi is slated to host a stage of the Euro Hockey Tour. The shiny silver shell will eventually round out the intended frozen raindrop design, leaving a world-class sports and entertainment arena to serve the city years after the torch has passed on. Meanwhile, builders have other big projects on their hands in the coastal cluster. For more ice-cold competition, spectators will pack into the Sochi Olympic Skating Center, built to slightly bigger dimensions to meet the demands of figure skating and short-track racing events. The center will also hold 12,000 people and start hosting international championships in late 2012.
This venue has a unique large-span rooftop structure. In terms of metal, we're talking 2,000 tonnes in total, linked by flexible connectors to the main frame of the building. This engineering solution will help to meet the highest seismic requirements and is absolutely unique in the Russian construction industry.
Plans call for the skating center to be removable, potentially for later use in another Russian city. It's a cash-conserving design that will give Sochi a top-notch skating facility for the 2014 Games, as well as the chance to choose their own future for the site in the years that follow. A speed cycling track is already among possible proposals. The command center for Sochi 2014 preparations is the offices of the specifically created construction company Olimstroy. With so much under construction and deadlines approaching, it's an understandably busy scene. Special attention has been focused on the sliding center back in the mountain cluster, future home to the luge, bobsled, and skeleton events. The unique track is already approaching completion in 2011. Unlike stadium sports like hockey or short track with tightly fixed layouts and dimensions, each Olympiad has a slightly different design for its sliding center based on the natural setting.
This particular site has favorable conditions. It's the northern slope of Mount Aibga, and there is less direct sun here. The ice will hold for longer, and so will the sports season. The mountain relief conforms to the geometry of the track going downward, meaning there will be fewer supporting structures. The track fits the contours of the slope's topography.
The Russian National Sliding Center hopes to overcome what many consider design flaws in previous tracks. As a luge death in frighteningly fast Vancouver last year reminded us, these are dangerous sports, and the builders are making for safer competition in Sochi. No matter how much we love the beautiful mountain views, not every day on the slopes can be perfectly sunny. The same snow that gives us our precious powder can also roll in really thick, and we need special equipment to prevent a healthy buildup from turning into a deadly avalanche. Ski areas have a very fragile relationship with snow. None is no fun, and too much is a ticking time bomb. When the levee breaks, it's an earth-trembling wall of white, weighing thousands of tons, moving at hundreds of kilometers an hour, sparing nothing in its path. The front line in the face of the snow situation is manned by avalanche control squads. In the 21st century, they're equipped with increasingly versatile technology. For accessing remote mountain areas, even in inclement weather, monitoring the size of drifts, and easing the buildup with remotely controlled snow blasts. No amount of new gear will replace their vital role in alerting skiers and running operations, but innovative ideas can make their job easier and safer. A key element in our avalanche defenses is a system of nets designed to hold back the ever-growing snow pile. But how can we monitor the tension built up behind these barriers without having to dig our way up here all winter long? The answer could just be right inside these unassuming little encasements. The basic plastic box design might not evoke Kandinsky or Malevich, but they're still made by a St. Petersburg-based firm called Avant-Garde, and they could provide a revolutionary function in the avalanche early warning system.
Our sensors measure the lengthening of the rope depending on the load it bears. When the rope is subjected to heightened tension, it stretches, and it's this slight lengthening that is detected and measured by our sensors. Radioelectronic modules inside the encasement can transmit the information about the strain to a remote computer so that any operator can immediately order a snow removal operation.
At their remote headquarters, Avant-Garde runs a monitoring center that keeps a constant eye on the distant southern Russian mountains. They're not replacing boots on the ground just yet, but they're collecting valuable data to model the snowdrift trends and alert their frontline colleagues.
The sensors run in autonomous mode, sending signals through wireless connections. The operator doesn't need to search for information. We live in the 21st century and data should be coming to us, not the other way around.
Detention sensors are a new concept being tested and improved on the fly. For hardware, that means seeing what weathers all seasons in the volatile mountain climate. Then there's the question of how the data received from the sensor net setup can best be incorporated into existing avalanche control efforts, eventually reducing required manpower.
In terms of scientific and technical development, we collaborate with a number of Western companies. For example, with the VTT Technical Research Center of Finland, several companies from Germany, Switzerland and France. We're participants in international projects and together we develop new, promising products.
In the mountains alone, Avangard makes products for more than just ski resorts, since roads, railways, and population centers also need avalanche warning systems, and the rugged terrain around them may be far more inaccessible for lack of slopes and lifts. Avangard's production also includes all kinds of microelectronic detection systems, with the most common applications for observing the state of urban infrastructure. These help monitor the stability of historical buildings, the safe flow of gas to residential complexes, the smooth operation of vital power stations, and the structural integrity of roads and bridges. The equipment generates a detailed status timeline to help diagnose potential problems. Avangard's technology is pinned on the principle that it's better to detect defects in advance than deal with the aftermath of an accident. Back in Moscow, we can check out how technology's not just making winter sporting safer, but also helping us separate winners from losers, rule abiders from rule breakers. A system to be used for Sochi Olympic hockey is already in place at this Moscow ice arena. It might not be the first thing you focus on when you're in the crowd at your favorite sporting event, but all-important refereeing has a high-tech new look. Since the outcome often hinges on close calls, Igor Vitorits's company Slow-Mo TV has partnered with the Continental Hockey League teams and stadiums to maximize the odds of getting them right. While you root for your team to put the result comfortably out of question, Video Referee has its eyes on a game of inches. Slow-Mo TV has adapted their strong background in video replay and multi-channel camera control systems to meet demands from professional hockey for a precise officiating assistant. Based on the client's budget and stadium infrastructure, Slow-Mo can install up to 11 channels of high-definition video monitoring. With all these angles at their fingertips for making any number of tough calls, judges are most concerned with a versatile, comprehensible interface when the pressure's on and time is of the essence. Unlike many other sports that have resisted moves to video-based refereeing mechanisms, hockey has fast-paced, close-confine decisions in droves. And the Russian League is actually out in front of the American NHL in tackling the situation with technology.
Our video referee system does not simply meet the international standards. We set the benchmark. It meets higher requirements than those defined in the regulations of the NHL or the International Ice Hockey Federation. So it's a very advanced tool, helping referees to take the right decision in 98 to 99% of goal line cases.
At this match in Moscow, home side Dynamo had the better record coming in and looked strong in early play. But the visitors from Novosibirsk were not about to be bullied in the last match of the regular season. Sure enough, just 6.5 minutes into the first period, Novosibirsk mounted a charge that had the lights flashing, the crowd waiting anxiously, and the refs making the call upstairs to the video referee. Down on the ice, it looked like a near miss off the pipe, but Slow-Mo TV's equipment was needed for a closer look. Goal or no goal? Were there any offensive players in the crease? After careful review, the replay confirmed the call, and Dynamo escaped with no goal surrendered.
Several years ago, the referees took decisions in disputed incidents on their own, and very often fans and teams' management questioned the ruling, saying it was biased. Since last year, we decided to stop this practice and introduce the position of video referee. For example, when the puck crosses the line in the last seconds of the game, it's not clear whether it was before or after the clock runs out. We asked the developers to display the time on the screen so that the video referee could decide. We had 5 or 6 such moments last season, and thanks to the improvement, the referees made the right call. And we could show the teams, look, if you don't believe us, we can always play back the tape.
So the video referee system works well for the KHL, confirming that Dinamo would enter the playoffs coming off a 2-1 overtime win. But what about all the hockey action slated for Sochi 2014? Slow-Mo TV's products will be in the Bolshoi Ice Palace, where goals could translate to Olympic gold.
We chose the Slow-Mo TV product first because it provides the functionality we need. Second, it's a reliable partner since many Russian TV stations have used its equipment for many years, mainly for multi-camera shoots of concerts or shows. So we can trust them. And third, it's cheaper than similar products of Western companies. And most importantly, it's much better.
Slow-Mo TV is already attempting to branch out to other sports. Basketball can come down to disputed close calls. Fencing to the slightest touch. Replays are often required to verify violations in short track speed skating, so more Slow-Mo products could still make the Sochi Games. Our work for this edition is done, but the Sochi 2014 construction team is still working to make sure we have plenty more updates headed your way. Join us again next month, and while the powder's still fresh, enjoy the ride.